What's up, AP Stats? Page 4 of the answers for the formative. So numbers 12, 13, and 14. I'm going to go through number 12 here very quickly, which is the explanatory variable. Remember, we have explanatory and response variables. Explanatory being the x. In this case, we have weeks, right? So weeks worked. Now, part B says, what is the correlation between these variables? So that's your correlation coefficient. What is this R value? Well, that's where we'd have to take all these values, put them in for list 1, put them in for list 2. In your calculator, run linear regression, a plus bx. You get an equation, and you get an R value. And in this case, you have negative 0.7. And of course, this tells us that the correlation is negative and very strong. Right, so there's a very strong correlation between the weeks that you worked and then how much time it takes you to make these parts in the assembly line. All right, and then letter C, it says you want to predict whether or not you qualify for that raise. So you're trying to see, like, should we actually use the equation that we came up with? So in other words, is a linear model appropriate? And remember, in order to see if a linear model is appropriate, we need to examine the residual plot. And I actually gave you the residual plot for this example. And the residual plot right here, you can actually see that there's not randomness. There's an obvious curved pattern here. So the data over here is actually curved. And even though we have a strong correlation here, the data is actually curved. So based on this, no, a linear model is not appropriate because the residual plot is curved, shows a curved pattern. Okay. Number 13. Number 13 says, indicate whether the association you expect between these two variables is positive, negative, curved, or none. Explain your reasoning. So the power level of a microwave, so how strong a microwave is, and the number of minutes it takes to boil water. So, I know some people are kind of like, what? You can boil water in the microwave? Yes. A little strange. I don't think I've ever done it. I feel like I would burn myself pulling out my cup or whatever it is I'm boiling it in. But I would assume that if the power level of the microwave is increasing, right? So if we have a stronger microwave, I imagine the number of minutes it's going to take to reach boiling, it's probably going to decrease. So if I have a really strong microwave, it should only take like less time to boil. So since one of our variables goes up and the other goes down, this is a negative association. We can say in general, as the power of the microwave increases, the number of minutes to boil decreases. All right, 14. I believe this should be the... Oh, we have a fifth page. We do have a fifth page. So, number 14. A couple years ago, a local newspaper published research results claiming a positive association between the number of years high school children had taken music lessons and their GPA. So what does a positive association mean in this context? In general, the more Sorry, I'm looking at my answer key here. So the two things we're talking about, number of years had taken music lessons and their performance in GPA. So in general, the more music lessons a student has taken, the higher their GPA. And we know that that's not always true, but generally speaking, since we have a positive association there. Now, letter B says that, like, oh, since we saw this correlation, school board saying that, hey, we need to, like, make every kid take music class. That way, all their scores will go up. As a statistician, do you agree or disagree with this reasoning? And just because there is a correlation does not mean that there is cause. So who knows if it really is the music classes that are causing the increase in grades, right? There could be other lurking variables. Or maybe these kids that are in music classes, they would have done well anyway in school. Yeah, so basically, causation is not correlation, so we can't just say or assume that adding music classes is going to increase the scores.